So we now have a carbon spectrum. Notice we have one peak around 170. This is likely a carbonyl, ester or amide. In this case it is an amide. And the rest of our peaks are between about 88 and 12 ppm. To distinguish our methylene, the CH2, from the methyl and methine, the CH3 and CH1, we can acquire a DEPT 135 spectrum. That one shows only protonated carbons, so we would not want the 170 in that region. And then carbons that don't have any hydrogens will not show up in the DEPT. And so peaks that are present in the carbon but not in the DEPT would be carbons with 0 hydrogens. To set that up, we will go to the Start menu and create Data Set. Note that the experiment number has been incremented to 3. So we will read in a new parameter set, click Select, and we have here C13 DEPT 135. If you have a long list, you need to check that box Show Recommended. That gives us the abbreviated list we have here. So you would click the C13 DEPT 135, click OK. We'll update the title to reflect that this is in fact the DEPT 135 and not a carbon. Again, click OK. And that sets up the experiment and adds it to our list. If we expand there, you can see it does say that this is a DEPT 135, what we had in the title. So going back to our carbon, remember between about 88 to 12 ppm is where we have our protonated carbons. So with the DEPT, we'll go to our acquisition parameters and we will change the parameters to collect only in that region, about 10 ppm above and below that. Let me need to scroll back up. Right now it's centered at about 80. We'll fix that too. But SW, the spectrum width, and we'll change to about 100 to go from 0 to 100. And then we'll want to pick the center of that range from 0 to 100. The center would be at 50 ppm. And so we will scroll back down. And where we have the parameter O1P, that's the offset. And again, we want the ppm. We will change that to 50 to have that in the center of that range we're collecting. So we're doing 100 ppm centered at 50. So that would be from 0 to 100 ppm. The other thing we'll change is the number of scans that we're collecting. Remember, for the carbon, we initially set it to 500. We collected a bit more than half of that. The number of scans in the DEPT can typically run easily half the number that we had in the carbon and get the same sensitivity, or same signal to noise. So we'll go to the Acquire button now. We've already done the lock, tune, and shim, so just ProSol, and then Gain and Go to acquire the spectrum. And as before, we're not going to wait for the entire process to finish. But since we're only doing 128 scans, notice the time is about 12 minutes. And so we can come back in 12 minutes and check the progress. As with the carbon, we can stop it partway, or we don't even have to stop it partway through. We can do the TR to transfer the data we've collected, and then Fourier transform and baseline correct to see a spectrum. And if we have the signal to noise that we find adequate before we finish, we can always stop it. Again, we do not use the stop button, but the square red button, the halt, which saves the data. So at this point, the data collection is done. We can go to Process Spectrum. And we have our Fourier transform baseline corrected phase-corrected spectrum. You can see here we have positive peaks, which are the CH1 and CH3, and negative peaks, which are our CH2s. We can do peak picking, same as we do with the carbon. Make sure that the peak tips are inside the green box. Note the negative peaks were not inside the box, so they were not selected. We can go back and pick those as well and add that to the peak picking. At this point we have all those selected, so we can save and return. At this point we have our DEPT 135. Typically when we are trying to do the interpretation, we compare this with the carbon, so it's useful to move it up and then to overlay both spectra. So if we come here, we have the multiple display. We can click on that, and then we can drag the carbon spectrum into the window, and it will automatically be put in with the same expansion. We do need to move those up and down by clicking on one. For example, the red is the carbon spectrum. It's highlighted, and we can move that down. The double-headed arrow and then scroll mouse or the mouse button, we can move that up and down. Then we can select the blue, the depth spectrum, and same thing, move that up to have them on top of one another. And whichever one is highlighted, if we use the scroll button on the mouse, we can make those peaks larger or smaller. And at this point we can see which peaks are CH2s and which are CH3s and CHs by the overlay. So this is a positive intensity. It's a methyl or methine. At that shift, probably a methine. But we can see each of those in turn. Since this is a negative intensity, that would be a CH2 peak. And again, another CH2. The ones at very low chemical shift are likely methyls, but we can distinguish those by doing a DEPT 90.